Hello, everyone, and welcome. Today, we're going to unlock a new superpower in calculus, understanding second-order derivatives. And I promise you, it's way easier than it sounds, and it's going to completely change how you look at graphs. So just imagine this for a second. You've posted an Instagram reel, it's doing well, the views are climbing, that's great. But the real question, the one that tells you if you're really going to go viral, is this. Is the growth speeding up, or is it slowing down? Right? Are you going from 100 new views an hour to 1,000, or is the hype kind of fading out? Well, that change in your growth is exactly what second derivatives are all about. And this slide connects that idea perfectly to the math. On the left, you've got speed. That's just how fast your views are growing. That's your good old first derivative, dy over dx. But the real magic is on the right, acceleration. This tells you how fast the growth itself is changing. That, my friends, is the second derivative, d squared y over dx squared. So what is this thing, really? Don't let the fancy names scare you off. It's actually a very, very straightforward idea. Let's just break it down. Here's the most important thing you need to remember. The second-order derivative is just the derivative of the first derivative. That's it. You find the derivative once, like you always do, and then you just do it again to the answer you got. You literally differentiate the same function 2 times. Simple as that. Now, in your NCERT textbook and in your exams, you'll see it written in a few different ways. Don't let this confuse you, okay? Whether it's d squared y by dx squared, or f double dash of x, or y double dash, they all mean the exact same thing, just different ways to write the same idea. All right, enough theory, enough talk. Let's actually do one. Think of this as your basic training. It's a really simple 2-step process that you're going to master right now. And here it is. This is the whole method. Step 1. You find the first derivative, dy dx. No problem. Step 2. You take the answer you just got, and you differentiate it one more time. That is it. Let's try it out with a real example. Okay, let's take this example straight from your textbook. Y equals x cubed plus tan x. Step 1. Find the first derivative. We know the derivative of x cubed is 3x squared, and the derivative of tan x is secant squared x. So dy dx is 3x squared plus secant squared x. See? Easy peasy. You're already halfway there. Now for step 2. We take that result and we differentiate it again. The derivative of 3x squared is a simple 6x. Now for secant squared x, we have to use the chain rule. Remember, first you deal with the power, the squared part, so that becomes 2 sec x. Then you have to multiply by the derivative of the inside function, which is sec x. The derivative of sec x is secant x tan x. So you put it all together, and our final answer is 6x plus 2 secant squared x tan x. Okay, listen up. This is a very common mistake. A lot of students forget the chain rule for that sec squared x. They just differentiate the square to get 2 sec x, and they stop there. That is completely wrong. You have to remember to multiply by the derivative of the inside part. Always remember the chain rule. Okay, so we know how to calculate it, but really, why should we care? What's the point? Well, this is where it gets really cool. The second derivative has 2 amazing superpowers that let you see the secret behavior of functions. So superpower number 1 is that it tells you the actual shape of the graph. It tells you if the curve is bending upwards or if it's bending downwards. And in math, we have a name for this. We call it concavity. Here's the first rule. If the second derivative is positive, so greater than 0, the curve is concave up. The easiest way to remember this is positive things make you happy, right? They make you smile. So the curve looks like a smiling face. Or you can think of it like a cup that's holding water. And if the second derivative is negative, so less than 0, then the curve is concave down. Just think of a frowning face. It's pointing down. Or a cup that's turned over and spilling water. So negative means down, just like a frown. Now, let's connect this back to our Instagram reel. If the second derivative of your views is positive, the curve is concave up, like a smile. That means your growth is accelerating. You're about to blow up. But if it's negative, the curve is concave down. You're still getting views, yeah, but the growth rate is slowing down. The hype is fading. See? It's like predicting the future of your reel. And now for superpower number 2. This one is the ultimate test for finding maxima and minima. This is how you can be 100% sure if a flat point on a graph is a peak, a maxima, or a valley, a minimum. This table makes it super clear. So first, you find a point where the slope is 0, right where dy dx equals 0. Then you check the second derivative at that point. If it's positive, it means the shape is concave up. It looks like a valley. And what's at the bottom of a valley? A minimum. So you found a local minimum. If it's negative, the shape is concave down, like a hill or a peak. So you found a local maximum. And if it's 0, well then the test fails and we can't be sure.
Okay, another big mistake alert. So many students mix this up because it feels backwards. But please remember, a positive second derivative gives you a minimum point, and a negative one gives you a maximum. Just always think back to the shape. Positive is a happy smile, concave up. That's a valley, so it has to be a minimum. So we've covered quite a bit. But what is the one single big idea? The main takeaway you need to remember from all of this?
It's this. The second derivative is simply the acceleration of a function. It doesn't just tell you if something is changing, it tells you how the rate of change itself is changing. Is that change speeding up or is it slowing down? That is the whole story. Fantastic work today, really. Let's just lock in all this knowledge with a super quick 30-second recap. These are the key things you absolutely have to take away from this.
Okay, remember these 4 things. 1, to find it, you just differentiate twice. 2, it's not about speed, it's about acceleration. 3, the sign tells you the shape. Positive is a concave up smile, negative is a concave down frown. And 4, you use it to test for peaks and valleys. Remember the backwards rule. Negative gives you a maximum point.
You've totally got this. Seriously, this concept is a real superpower in calculus. It helps you understand exactly how functions behave. And now you know exactly how to use it. Well done.